this is taught like a regular class at many schools, and it requires daily classes. So although it's not that difficult, it's still important that you guys put in some effort in your own time, like during the weekends, which is what I used to do. And then as for, a lot of people have been asking me about laptops and whether they should bring it. So you guys can, starting next meeting, not this meeting, but you guys can use the laptops in this room or bring your own laptop. But I would like to point out that any damage or theft of your laptop is not any of our responsibility, and we're not liable for it. So just to get that clear, but yeah, just in case. So you guys can bring your laptop. We'll be installing JDK, which is the Java Development Kit, next week, and we'll be going from there. Okay, so now I'm going to overview the AP Computer Science test. So the test is 1 hour 85 minutes, which is a little bit, 1 hour 75 minutes, which is almost 3 hours, and 40 multiple choice, 75 minutes. So you have a little bit less than 2 minutes per question, which is a pretty good amount of time. And then 4 free response questions in 105 minutes. So you have about an hour and 3/4. Now, the thing about the FRQ is many people believe that you bring like a laptop or you use their computers to write your code. But in actuality, you have to write your code on a paper and it gets graded like that. So we're going to be practicing using a computer as well, because we want to prepare you outside of this class so that you can use coding in the real world as well. And many people also believe that it's based on like a lot of code, but it's really about logic, and that's the most important thing in computer science. It's about establishing logic so that you kind of understand the back end behind some code, so you can like understand what it does. And there's some notable changes from last year. So for example, there's something called the grid world study, which is just some code that they want you to kind of memorize and understand things about it, and there's always some questions about it. And it was something that people didn't really like, but they removed that this year, and they've replaced it with a requirement of 20 lab hours, which basically means that you need to have an APCS class to be able to take the test. So I am speaking with Mr. Moran, and he will probably sign us off and give us all of us the hours, so we'll be qualified for the APCS test. And then, just in case you didn't know, all the code will be in Java for this. So first question, we're going to dive right in. If you guys want to take notes, that's cool. And then, it could be useful for you in the future, but we will be posting everything online. So does anybody want to tell me what a computer is? No? Nobody? No? Okay. Alright, so a computer is a device that can perform computations and make logical decisions faster than a human being. And you guys have computers in front of you right now. This can make decisions and calculate things faster than you can, in case you don't know. And computer programs are basically a set of instructions written in code that the computer understands and does. So for example, imagine your teacher gave you a sheet with instructions on it, and then you read it and you performed the actions. So similarly, for computers, you would write code, the computer understands the code, and then does what you tell it to do. And the computer is like a robot, it's stupid, it doesn't have common sense, so you have to explain every single small thing to it so it knows what it's doing. So now I'm going to talk a little bit about software versus hardware. So does anybody know the difference between software and hardware? Anybody? No? Yeah.
Software is like code, like programs, and hardware is what it runs on.
Yes. Can anybody give me an example of hardware?
Computer.
There's a lot in front of you. Yeah. Yeah. CPU, the keyboard, everything's a form of hardware, and software is like the actual code. So think of it this way: you can see the hardware, but you can't see the software. And then for coding in real life, the APCS is like a really small. It's just like a step in the door to coding. But it's a really critical step, and it's important that we establish a strong foundation. So when you guys learn more advanced concepts in the computer science field, it'll be a lot easier to grasp. And it's very useful. Jobs are pretty good, the regular, and then it's a fun thing. You can use it to whether you want to create your own website or you want to make a small app. It always comes in useful, even if you're not necessarily going to do computer science for your whole life. Good. Okay, so there are 6 logical units in a computer. There's an input unit, which is basically something that gives information to the computer, for example, a keyboard, or even receiving information from the internet. So that's an example. Then output is what the computer displays. So that could be like printing something or sending information to the internet, or like just printing something on the screen. That's an example. Then we have the memory unit, which temporarily stores information, so when you're making calculations. And the thing about this is it's volatile, which means that when you sleep or shut down your computer, that memory is not safe, so it's automatically cleared. Then we have the ALU, which is the arithmetic and logic unit, which does the calculations. And then we have the CPU, which is the central processing unit and does the major amount of calculations and carries the most load. And then we have the secondary storage unit, which has the same function as the memory unit, but unlike that, it's persistent, which means that even when you shut down or sleep your computer, it's still going to save all that information. So all of these 6 units work together and work with each other in order to make the computer function. Like for example, when you input something, that will be temporarily stored in the memory unit, and then it will be outputted when the computer asks the memory unit for the information, then it's going to be outputted. So they continue to work with each other, and that's how the computer functions. Do you guys have any, can you guys think of any examples of an input unit? No? How do you get information into your computer? Huh? USB, yeah. Anything else? Yeah. Like a keyboard, something like that, yeah. Okay, go ahead. Okay, so now there's 3 different types of languages. The first is machine language, which is computer's language. And it's just a string of numbers, so it could be like, for example, 13000427744, which is something that we can't understand, and even if we do manage to understand, it'd be very difficult to code it. So thankfully, we don't have to write code like that, and instead, instead of that, there's also something called assembly language, which is where you add some like phrases of English in to make it more readable. But the problem with that is, it's like you can't complete multiple functions in one sentence. So let's say that I wanted to add 2 things together. I would have to say first x equals 2, then in the next line I would have to say x equals 3, then I would have to say x plus y. So you have to split everything into lines, and it's very tedious. And then high-level language is what we're going to be coding in, thankfully, and it's one form of it is Java, and it's Common English. So a way to think of it is the first one, which is 13,42774, is machine language. Then something like load base pay would be assembly language. And then the third one, gross pay equals base pay plus overtime pay, is something that you would consider to be high-level language. And then along with that, when the computer receives machine language, it converts it into zeros and ones, which is known as binary. And that's something that's very difficult to understand, because everything the computer does, it interprets zeros and ones to do it. And like a long time ago, programmers used to have to code in that, and it was very difficult to do so. But now we can use Java, which is very similar to Common English with some addition, subtraction, multiplication. Okay, so a little bit on the history of Java. So does anybody know who Java was created by? Anybody? The company? Yeah, good job. Okay, so yeah, it was created by Sun Microsystems. And it was actually called Oak originally, but then they decided that name was bad, and there was already a language called Oak. So they changed it into Java when they were at a coffee shop, and they just started Java chip Frappuccino. And then there's basically, as I said, Java programs are a set of instructions for the computers. Now within those programs, there's something called classes, and within those classes, there's something called methods. So I'm not going to dive into that too much today, but classes, you can basically think of that like inheritance. You can think of like programs as like the great-grandpa, the classes as like the grandpa, and like the method as like the father. And then there's Java class libraries, or also known as APIs, application programming interface, and they're existing classes that you'll use. So when you're writing Java, you're gonna have to like do things like addition in your code and all of that. And they're already pre-built classes. So how does the computer know how to do addition? You basically import a class, which means that you use some pre-existing code that's standard, and the computer knows how to perform addition now. And these are very useful. They're actually critical. It would take you forever to code if you didn't have these, and they're on the Java website, which is java.sun.com. No. Okay, so now I'm going to talk a little bit about object technology and UML. So UML is Unified Modeling Language, which is basically a graphic language. So you can be able to like basically map your program. And one thing that's really important about coding is because it's based on logic, you want to kind of set an order for everything that happens rather than just starting to code. You want to know exactly what happens and structure it out so it's much easier. So I'm going to give you an example of UML. Okay, so this is a really brief example of UML, but basically what's happening is, let's say the program is started right here, you come down here, and then there's an if block. An if block means that let's say that x is equal to 3, right? If x is equal to 3, then, okay, and then x is equal to 3, so the computer starts, x is equal to 3. When it comes to the if block right here, it's going to ask, if x is greater than 5, print x is awesome. If x is not greater than 5, then don't print x is stupid. So in this case, because x is greater than 3, you'll see that, x is 3, you'll see that it's less than 5 and it prints x is stupid. Now this is an extremely basic program and something that you probably wouldn't need to map out. But as you guys get more advanced in the field, you'll see that like these type of programs are extremely complex and it's necessary to do this. Otherwise you'll have no clue what you're doing. So as we start this class, we're going to start doing this from the beginning, even for the easiest programs, because it's important to build this foundation because it's a very, very important habit that you'll need. And then, okay, so before I go into objects, I'm going to say that objects are everything around us, right? Like this pencil box, a stapler, a book, right? Now they have attributes and behaviors. So let's take, for example, the stapler, right? The stapler, it's one of its attributes is it's black. Another one of its attributes is it's smooth. Another attribute is it's like solid, it's relatively hard. And then some of its behaviors are it staples. So if you staple it, it staples. You can also use it to hit people, throw it at people. So these are all behaviors. You can think of behaviors as actions, and so think of behaviors as verbs and attributes as adjectives. So now OOD is object-oriented design, and it uses classes and inheritance. So I'm gonna give an example of this. So think of a class as a vehicle. A vehicle is like a group, okay? A class is a group. Think of a class as a vehicle. Now inside that class, there's a lot of things like SUVs, motorcycles, right? Now one thing we know about a vehicle is that it moves and it has wheels. So now all of the things that are in the vehicle class, like SUVs, motorcycles, cars, RVs, they're all gonna move and they have wheels. So that demonstrates inheritance, which is basically that any object within a class will have the same attributes and behaviors as it's basically as the class. So all the objects and vehicles will have the same attributes and behaviors that vehicles do. And this is like the central part of object-oriented design. So basically it's based on objects and you're just inheriting so your work becomes easier and you're transferring attributes. So think of it kind of like as a father-son relationship. Like if a father is tall and has brown hair, the son will probably be tall and have brown hair. So another thing about object-oriented programming is that classes make up other classes. So in order to make a program, you combine different classes together and you get an overall program that the computer understands. Now, associations are relationships between classes. So basically, if a class would tell another class what to do, I'm saying this all theoretically right now because we're actually going to dive in and do everything interactively next week. But right now, the relationships between classes are called associations. And they're just basically when the classes communicate with each other or have something in relationship. And when you're coding, it's first important to analyze the requirements. So what I tend to do is when I code, I start off by putting a small note to myself, which I call a comment on top of it at the beginning of the program, where I know what the requirements are and how I'm going to do them. this is pretty much, this is again like UML. It seems like something that's not smart because it's a relatively basic concept, but it's actually extremely useful when programs start to get a lot more complex. And then you basically develop the design. So you kind of, after you know what the requirements are, you would make a design like this one and completely map out the logic, and then coding becomes a lot easier because, as I said at the beginning of the class, coding is just basically just logic. And once you know the logic, coding is the easy part, logic is the hard part. So if we start this class and like continuously, like habitually, try to master the design and the logic, coding is going to become something that's actually relatively easy. And then there's also something called pseudocode, which is something that they actually would like you to use in the APCS test occasionally. So pseudocode is just basically, for example, rather than writing your code with like, code looks kind of complicated. So rather than writing code, when you're just thinking of the logic, I might write it like this. I might write x equals 3, and then I might write if x is greater than 5, show this. So now if I were to use this as code, that would not work because that's not right code. But this is something called pseudocode, as I said. So basically you're just thinking of the logic in your head and you're getting a general idea of each and every step. Now this pseudocode and UML are interchangeable, so you can use whichever one you prefer. People tend to use UML because it's more graphic and much easier to use. But pseudocode is also something that's really important, and it can really help you get a general idea of every single part of your program. Alright, so that's pretty much all I have because we're trying to keep it relatively basic. From the next class, I'm going to start giving you guys a lot more assignments to do in class. We're going to start making it more interactive so you can use the computers in front of you. Today I didn't want to overwhelm you guys, but it'll be a lot more interesting. So Ganesh is recording this right now and we'll be posting this lecture online. And then along with that, I'm also going to try to record another lecture this weekend, which is basically going over everything I did today, but without like the class environment, so it's more clear for the people who couldn't make it. And then another thing is, like, if you guys, I know some of you guys are already ahead and like already been studying. So if you have like, if you have any questions about the test, or you're stuck on a problem or anything, feel free to stop me anytime during school or message me on Facebook, and I'll be quick to help you guys out. So we're gonna end with some questions. I'd love it if you guys like showed some participation now. It feels kind of weird just standing up here and talking to you guys. So let's see how smart you freshmen are. Okay, so question 1, pseudocode is A, another term for OOAD. B, a programming language for UML. C, the informal means of expressing program logic. And D, graphical representation for OOP. Alright, so hopefully everybody should know this because I just went over it, but you?
C.
C? Okay, yeah, good job. Alright, next one, let's see, this one might be a little bit hard. This was hard for me. The UML is primarily used to A, test object-oriented systems, B, design object-oriented systems, C, implement object-oriented systems, and D, both A and B. Does anybody have a guess? D? No, that's incorrect. Leo? B. That's correct. So realize that you can't test it because it's not code, so you can't test it. So UML is this right here. So this over here is just to design the logic, but you can't actually test this because a computer wouldn't be able to comprehend it. Okay, next. Okay, so I want you guys to give me 3 examples of real-world objects and list some of their attributes and behaviors so you understand what objects are. Yeah? And what are its attributes? Like talk about like its adjectives, like it's black or something red. It's red. Oh yeah, there's like anything else? Anything else about it? Like how hard is it? Okay, that's good. Anybody else? No? Nobody else knows what an object is? Yeah, Sai. A human, okay.
And then attributes would be like height, weight, hair color.
Attractiveness.
Yeah, that's actually
Behavior is like
That works.
eating, sleeping.
Okay, yeah, please like pay attention to objects. That's like one of the most important parts of coding. And Java is all based on object-oriented programming, which is an extremely important part. So anybody else have some more objects? You guys need to start loving objects. Yeah.
A map.
Okay.
It's like colorful and there are like different sections and its behavior is that it like tells you where this is on.
Yeah, exactly. Anybody else? Yeah, Leo.
A chair.
A chair. Okay.
So the color is berry, but it's black.
Okay.
Has 4 legs. Can be used to hit somebody, down on, stability.
Exactly. Okay, last one. Anybody else? Anybody else gonna give me an object? Somebody? All right, Abhishek, give me an object.
So your pants black.
They're black. Okay.
And have stripes. And then they use for wearing and they're covering your.
Okay. All right. That's a great example. That was my favorite one. All right. Go ahead. All right. This one, if you guys were listening, so this was actually a question that was thrown at me on the APCS test, and it was not something that I was prepared for because the variance book doesn't go over it. So that's why this introductory lesson is extremely basic, but it goes kind of some of the miscellaneous stuff that shows up. Does anybody want to give a jab at it? Yeah.
Okay, input, output, memory, ALU, CPU, and secondary storage.
Okay. Can you tell me what what ALU stands for? Yeah. So, yeah, did everybody hear that? Arithmetic and logic unit. So it performs all the calculations. Now, okay, somebody want like extra credit that's not going to actually come, but you can be proud of yourself. Does somebody want to tell me the functions of some of them or give me some examples of them? Even one of them. An example, yeah. Okay, but the thing with memory is, so it's volatile. That means that when you sleep your computer, right, it's not safe, right? So this is, so that's one thing that people get confused a lot. For what you're talking about, that would be the secondary storage unit, which is kind of like a hard